This video is about the change of base formula for logarithms. For our notes, we're going to suppose we have log base a of x, but we want to find log base b of x, which would amount to changing the base from a to b. So first we're going to develop this formula or way of doing it, and then we'll use the formula and see how it might be practical, especially with a calculator. We're going to start by saying let y equal log base b of x, and then we're going to convert that equation to exponential form. So as we know by now with the definitions, we could say b to the power of y equals x. Then we're going to apply log base a of both sides of this equation, so that now we have log base a of the left side, which is b to the power of y, equals log base a of the right side, which is just x. Next, we're going to apply the power rule of logarithms, or the power law of logarithms, but only to the left side of our equation, where we have this y power of b, and we're going to throw that y down in front, which is consistent with what that power law tells us, and that would turn into y times log base a of b equals, and then the right side will remain the same, log base a of x. Then if we divide both sides of our equation by log base a of b, then of course the log base a of b's on the left side would cancel, leaving us with y equals the right side, which is log base a of x over log base a of b. And so if you connect the beginning and the end of what we have here, we started with y being equal to log base b of x. Now we have, at the end of our little process here, y equal to a quotient of logs, but notice now these logs have a different base. It's now base a. And so this is how we can use this process and laws of logarithms to convert a base. In summary, we'll say this: log base b of x is equal to log base a of x over log base a of b. And so this is what is known as the change of base formula. You're starting with an expression that has base b, and you're turning it into an expression that only has log base a. And so you might ask, well, where did a come from? Well, that's kind of the point. You can change it and turn a, or pick a to be whatever you'd like. And there are some convenient choices based on what the calculator will offer us. Let's try an example where we use the change of base formula and a calculator to evaluate log base 12 of 2.5. Now, as you'll recall from a graphing calculator, there is no button for log base 12. On the TI graphing calculator, as we've been using already, you'll notice on the left side, most of the way down, you'll find two buttons, log and ln. Remember, log log is log base 10, and ln is log base e, but we want log base 12 in this case, which means we need to change the base. So first let's attempt to use the change of base formula and compute this. Let's take our desired expression of log base 12 of 2.5, and using the change of base formula we could rewrite this using any base we'd like. Now let's choose a base that's already in the calculator. So you could use just the plain log, which is log base 10, or you could use natural log, which is log base e. But either way, if I use, for example, here just the plain log, log base 10, then I'm going to take the input that was there in the original expression and put it in the numerator. So I want log of 2.5 in the numerator. And then I take the base of the original expression and put it as the input in the denominator. So I want log of 12. So this is applying our change of base formula as we just wrote. We'll now type this in as we see it with log of 2.5, and we'll be sure to close parentheses with this input. It will not work out correctly if we are lazy with the parentheses here. So we want log of 2.5 close parentheses, that's our numerator, and then we want to divide that by log, again I'm just choosing to use the plain log base 10 here, the denominator is log of 12, close those parentheses, and then we'll hit enter and get a result. So if we round to 4 decimal places, we have 0.3687 as given by the calculator. Now, just to demonstrate that the base we choose when changing the base doesn't actually matter, as the formula says, let's try computing the same value but using the ln, the natural log key, this time instead. So we'll try natural log of 2.5 as our numerator, again close parentheses, divided by natural log of 12, close parentheses. Let's hit enter and observe that it's the exact same value, which goes to say that if you go back and look at the formula, when you change to a new base, you can pick any base you'd like. Of course, the convenient choices are base 10 or base E, because as we just demonstrated, those buttons are already on the calculator.